Okay, so make sure you put your class period, and there's a Math Excel due Wednesday, 11:59 p.m. And this packet is due Thursday. You will need to finish it. So, in other words, we're going to do the vocab support and the reteaching together, and we're going to probably do K together, but then you do the G. So I kept it all one stapled packet just to make it simple, but we're going to do what we normally do together, and then you finish it. Okay, so on this one, first off, these are your note cards with the statements and reasons. How we do this is, remember, cross out this part, and we'll end up just putting numbers here. So the whole goal on this one is prove BD is the perpendicular bisector of AE. We don't know they're the perpendicular bisector yet. That's what we're going to end up with. Okay, so what we usually start with is the given information. So I'm going to put a 1 there for a reason. And it's telling you BC is congruent to DC, and these are right angles, and these lines are parallel. Okay, whenever you know lines are parallel, then that's going to be a pretty good clue that you're going to set angles equal from the definition of parallel lines. Like two parallel lines cut by a transversal, so in this case alternate interior would be congruent. So that's going to be a 2 for this one. When parallel lines are cut by a transversal, alternate interior equal, and it's going to be A and E. So the BAC angle and the DEC angle. So there's a 2 right there. Okay, so far we have the 1s and the 2s. Now, we also know that if we have right angles, that'd be congruent. So the ACB and the ECD are going to be 3, and all right angles are congruent. The order for 2 and 3 didn't really matter because both things were given. Like, it says it's right angles and you have your parallel lines. So that's how I'm doing it, though. Now, what do we have? We have an angle here, and a side here. Angle, angle, side. And this says AAS theorem. So what we're going to do is we're going to say our triangles are congruent from the AAS theorem. So that's going to be this one. So anyway, what we're doing is we're proving the triangle's congruent, and then we can say anything else that corresponds would be congruent. Like in this case, they're using AC with EC. So this would be statement 5, and that's from CPCTC. So we put a 5 right there. And normally that's where the proof would end, but we were trying to prove it's the perpendicular bisector, and so we'll put definition of perpendicular bisector. And BD is the perpendicular bisector if it has right angles and these sides equal. So this does end up working out. So on the left side you should have 2, 5, 4, 6, 1, 3. That sounds like somebody's telephone number with more. And then this one's 6, 4, 2, 5, 1, 3, etc. Okay. All right. So here's a sample, and we want to do the 2-column proof for this. The first thing says given, so it's going to be this stuff. MN congruent to MP, NO congruent to PO. So that's your given part, and they already put the next part, which was MO congruent to itself. So you should remember from the last test, that would be reflexive. Reflexive. Now we have 3 sets of sides equal, so that means we're going to say side, side, side for our reason, and we've got to put our triangle. So triangle MPO congruent to triangle MNO. So that would have just been a 3-step proof using the information from a couple of lessons ago. Now we have these random angles are equal because of CP/CTC. So the simplest problem in all of these is just going to be prove the triangle's congruent and then CP/CTC. Okay. This next one is going to talk about certain things that I need to teach you real quick, like about a median and an altitude. So I'm going to do that up here. You need to write this. So altitude means it's going to be a height and a right angle. Altitude means it's going to be a height and there's going to be a right angle. So for example, if you drew a triangle, I'm going to exaggerate how wide it is, but this would be your altitude right there. I'm going to just label it A. So it's the height and it's a right angle and it's from a top vertex. From a vertex. So altitude means it's a height. You're going to have a right angle and it's from a vertex. The next part is about a median. And you're going to have the 2 segments congruent and from a vertex. So in this case, if I did that exact same triangle, instead of drawing it straight down, I've got to make it where this side equals that side. So something like that. And I'm just going to label this M for median. There are a lot more pieces of triangles than that, but that's all we need for this particular problem. There's an orthocenter, an incenter, I mean all kinds of vocabulary. But at this point you just need to know altitude and median. So the median does touch the top, but then it makes it in 2 equal pieces. Okay, so now let's get to our proof. And on some of this you're going to need to work backwards. This says PT is a median, which we know is given. And if it says definition of median, then we've got to figure out what goes here. So because of that, we need to draw our figure. In our case, PT is both a median and an altitude. So that means it's got to be a right angle and equal pieces. So what that means is it's got to be like this. Okay, so I didn't draw this perfectly to scale, I see now, but basically this one should be the same as this, so if you want to draw it out further, and what we have is PT is both the median and altitude, so P is here, T is there. PT would be the altitude because it's a right angle, and it'd be the median because these are equal. And then our other parts, we're just going to put S here and R there. So what you're doing is you're learning right now about altitudes and medians, and we're going to use that in our proof. So remember, we're working backwards in this proof. So this one says definition of median, so that means we're going to have ST congruent to RT. Let's see. The way the proof works is the T is the middle of this, has to be first. So T is going to be the midpoint. T is the midpoint of SR. So that one you had to work backwards from number 3 because it says definition of midpoint. And then the next one is where we need this one equal this one. So ST congruent to TR. So we have T as the midpoint of SR from definition of median because T would automatically be a midpoint, and then because of that, those segments would be equal. Any questions about that? Okay, number 4, PT is an altitude of PRS. That's another thing you're given. So we put given there. And then you have your upside down T, which means it's perpendicular. That'd be definition of altitude. Definition of altitude. So these other things said definition of median and midpoint. In our case, we need definition of altitude because the word above it was altitude. Remember, that's how it works. If you've got a word here, then the next one would be definition of that word. Just like here was definition of median, so we have median here. Okay. Now, it says these are right angles, and it's because on an altitude you have perpendicular lines. So this would be definition of perpendicular. Definition of perpendicular. Okay, so whenever you have an altitude, you have a right angle, and so that's definition of perpendicular. If you get to that point, the rest of it is kind of easy. The next one says all right angles are congruent, and it tells you which ones were the right angles that we use. And so we put PTS equal PTR, and put your little wavy symbol because it's congruent. All right angles are congruent. Then for the reflexive, it'd be this middle part, so PT congruent to PT. And then we have our side angle side next, which means we need this triangle congruent to that one. So let's just use it in the same order. So we put triangle PTS congruent to triangle PTR from side angle side. Now that we know the triangles are congruent, then we can put these angles are congruent from CPCTC. Corresponding parts of congruent triangles are congruent. And then we end up with our proof statement, PT congruent, PT bisects angle RPS. So let's see, TPS was this angle and TPR is this angle. So that means this is an angle bisector. Definition of angle bisector. Definition of angle bisector. Let's just move that up a little bit. Okay, the next part says write a 2-column proof for this one. This will be shorter. It'll just be 5 statements. The first one is your QK congruent to QA and QB bisects angle KQA. That reason is going to be given. So I'm putting statements on the left, reasons on the right. I'm going to put a number 1 given here, just to keep it symmetric. The next one, based on the definition of angle bisector, if QB bisects KQA, then this angle is equal to this one. So KQB congruent to AQB. This would be definition of angle bisector. Definition of angle bisector. Then, in order to prove our triangle's congruent, we're going to use this congruent side, reflexive side right there. And so that'd be QB congruent to QB. So that'd be reflexive. QB congruent to QB is reflexive. And then we'd have side angle side for our triangle. I will label this KQB this time, congruent to triangle AQB. Okay, so that looks like what we did a couple of lessons ago. And then the last part is we put this proof statement. That's how you know it's over. KB congruent to AB. This one equal to that one from CPCTC. So you do your regular proof, and then you have one extra step, which is CPCTC. Any questions? Okay, on this one, our given information for number 1 is ON bisects angle JO H, and angle J is equal to angle H. If you want to mark out this S, the worksheet had a typo. And that one's given. Okay, so based on this word bisects, over here we're going to end up with definition of angle bisector. And if ON is the bisector, then this angle is equal to this one. So angle John congruent to angle Han, or Han. So JON congruent to HON. Definition of angle bisector. Okay, John and Han. Number 3, this one we have to use the reflexive side right there. So that's on congruent to on. And that would tell us enough for angle side. I'm sorry, angle side. So triangle John congruent to triangle Han from angle side. And then our last statement would end up being this JN congruent to HN from CPCTC. Okay, so that's all of the vocab and the reteaching. I'm going to keep it there for a moment. Okay, let's go ahead and start a couple of these. This one says state why the triangles are congruent, then list the other parts that are. So on this one we've got an angle side. So we put AAS, and let's call it QSR. So triangle QSR. Triangle QSR congruent to triangle TXW. So from there, the rest of it would be angle Q equal angle T. We've already got our other two angles. And we've got this side, so now we need the RS side equal to, or congruent to, the WX side, and the QS side congruent to the TX side. Okay, for today, that's where we're going to stop. We're going to continue this tomorrow, and then there's more on a different practice you'll need to do.